Hello, my name is Mackenzie Grayson, and today I will be talking about the spectroscopy of simple molecules. First, spectroscopy is the study of the interaction of matter with the electromagnetic spectrum. Electromagnetic radiation displays the properties of both particles and waves. The particle component is called a photon, which is a small massless particle. The purpose of experiment 3 was to identify an unknown compound using spectroscopic techniques, and this was accomplished by using the infrared spectroscopy, also called IR, and the nuclear magnetic resonance spectroscopy, also called NMR. Both of these techniques measure how much electromagnetic radiation is absorbed in a sample. However, the two methods also differ. For example, the IR spectroscopy measures the absorption of a photon in the infrared region of the electromagnetic spectrum, and electrons are not affected when there is an increase in energy. Moreover, the energy is perceived as heat, and it shows which functional group is present. The functional groups can range anywhere from a carbonyl to an alcohol, and each of these functional groups absorbs a different frequency of IR radiation. Therefore, more than one functional group can be present in a molecule or IR reading, and for this reason there are multiple peaks throughout the reading. Yet, sometimes it is mistaken that a peak is present, so one should always look for a strong broad peak to assure a functional group is present. The NMR reading shows how many different types of hydrogen atoms are present and the relative number of each hydrogen atom in the molecule. At different frequencies of the radio region, the absorption peaks of hydrogen atoms will appear. Moreover, one should only count the number of larger peaks in an NMR reading. During the lab period, the information provided about NMR and IR readings guided the students to determine the unknown molecules. For example, this graph tells the different functional groups at different range of absorptions. However, we did not have the proper equipment to actually perform the real lab experiment, so we just used pictures of the readings. If we were to have performed the actual experiment, there would have been different steps to follow. First, one would prepare a sample in the regular lab room. Then one would attach the tip of the automatic pipetter to set for 40 microliters in the pipette volume of the NMR unknown into a clean NMR tube and record the number. Then the NMR tube would be placed in the measuring tube, and then NMR solvent would be added until the liquid level was between the lines. Next, one would cap, mix, and take the sample to the NMR room, where the instructor would assist one to record the C and H NMR spectra. For the IR, it would be placed in the Perkin-Elmer infrared spectrophotometer. This would aid one in figuring out the types of bonds of the sample. And for the method we used, we were given a chart with 15 molecules, and functional groups were placed beside them. This was shown so it could be indicated which functional groups would be present. After completing the IR chart, it was concluded that methanol, ethanol, T-butanol, and T-propanol all had an alcohol or a hydroxyl and a singly bonded carbon on a hydrogen. However, acetone has a carbonyl functional group along with a singly bonded carbon on a hydrogen. This was determined by looking at the skeleton structure of the molecule. For the NMR reading, it was concluded that methanol has 2 peaks with a 3:1 ratio, ethanol has 3 peaks with a 3:1 ratio, T-butanol has 2 peaks with a 9:1 ratio, T-propanol has 3 peaks with a 6:1 ratio, and acetone has 1 peak in a non-alkyl ratio. Here's a chart of my IR and NMR unknown readings, but I will further explain them. For 37I IR reading, it was shown that there was a carbon singly bonded to a hydrogen because the wave number was 2,993.20. For 30, there was also a carbonyl because there was a wave number at 1,759.91. For 37F IR reading, there was a large peak at 3 3046.60, and there was a large wave number at 2922.85, indicating a carbon singly bonded to a hydrogen. As for 37K, there was only one peak at 2958.63, indicating that there was only a carbon bonded to a hydrogen. For 37I, the NMR reading showed 3 peaks, which indicated 3 different hydrogen molecules, and it also had a 3:3 to 2 ratio. For 37F, there were 2 peaks, and there was a 3:2 ratio. And for 37K, there was only 1 peak, and there was no ratio. Therefore, 37I is ethyl acetate, 37F is paraxylene, 37K is benzene, and the IR and NMR spectra aids one in telling the structure of a molecule and indicates which unknown molecules are present. And here are my references.